Oh, thank you for a great introduction. Indeed, I forgot about that, but I recently posted on LinkedIn about it. So yeah, generating one platform at a time. So what are we talking to about today? Yeah, well, basically the title says it all. I don't think everybody will get it from the title, but I'll try to walk you through it. It's mainly about well, how coding, how we at Stacks with our own MyStekz platform. But I'll try to limit the screen time for the MyStekz platform. But how we do that, how we use that, how we emphasize the modeling, and then generate platforms from that. And I hope to share you a little bit of a live demo, but bear with me, it might or might not work, as we always we know. So this is back in 2024. I actually want to put a picture of our own CTO here, but just to banter a little bit. But yeah, just point AI at your code base, and all will be fine, right? So we got these tools. Well, most of you probably know Cloud Code, or maybe Lovable if you're less into day-to-day coding, or Mistral Vibe, or Gemini. Well, some other tools there. Yeah, well, we use these tools. I think maybe a show of hands a little bit. Anybody not using these tools, put your hands up. Okay, 2. So, well, I hope you will still enjoy this talk. I think you will. But tell me afterwards. So most of you know that these tools and the choosing to not use them is probably for one of the reasons that maybe it might be a reason. I'm now just filling in for you guys, not for you personally, but that it just doesn't work out because you create a lot of code and then, well, you end up somewhere, and that's not the point where you actually wanted to end up. Might be a reason, might also be different reasons, legal reasons or whatever, of course. But one example of this is that you just write a piece of code, you look at it, and you're like, yeah, this code, it looks pretty fine, right? But then you see that something gets approved before it actually is ensured to be compliant. Well, something you should, of course, well, find in your merge requests if you see something like this. Simple example, but it still happens. And when you get like these merge requests with 1,000 files changed, then you will not pick up on all of these kinds of changes. So that's well, that's reasons why just throwing AI at it doesn't work. But also you get some questions. Well, why does this actually happen? Or who should do this? Or what? All these kinds of questions that you cannot always answer from your code. Your code used to be actually, or still is, of course, the best specification for the problem you're solving, if that specification is correct to match your intent. So yeah, that's basically my question. Where is the intent? You could say, as I think as programmers, we will say, yeah, that the intent is in the code, right? Because you see, this is what is actually executing it. This is what is working. But if we speak to like the people who have the idea or who want to construct the thing, yeah, then there's a lengthy process from like someone who a business who wants to change something or wants to have something, wants to do something, into like eventually this code. So the intent basically starts from the business side already. And some of you might be coders who create their own ideas and then construct that. But most of us are actually working in a business with multiple people where an intent and the actual code, they are not the same. They never actually are exactly the same. So yeah, basically you started with AI when you had like autocomplete here. So I think most of you have worked with autocomplete. Then you got functions on demand, or you just wrote an individual function. But from there on, we actually started writing plans, maybe with Claude, with whatever. We write plans and then generate features. So actually, the previous talk was with my colleague. He showed that basically a very similar thing, but it was a graph with a line going up, saying like how long an agent can work autonomously, and that is also increasing and increasing. But like working autonomously doesn't mean that it can, if you just autocomplete stuff, then it cannot work autonomously for long. So you need better plans, better specifications, and better models to actually make the result match with what you have. So yeah, I thought I could visualize it a little bit like this. Here you have eventually you have the code, but the code is actually the thing that is surfacing from the whole model and the ideas behind it. So my take is that the model is actually the thing that bears the heavy weight, that the thing that makes eventually your code float. Because, well, I'm not saying that like everybody is doing this, but we should be doing probably the thing on the right side. I think everybody, well, I think most of people already agree with that, regardless of whether AI is used or not. But I do find a lot of situations where actually this is still happening. It's like, yeah, okay, you write code, and in like, I was going to say the old days, but when you write the code by hand and manually, then when you actually write the code, then you also do some of the modeling, right? So you write the code, you think, you reiterate, you think about it. So it helps you like thinking or constructing this complete model in your head if you haven't already done that and you run into problems. If you use AI-assisted coding, like a coding agent, then, well, when you do the writing code, then you don't get this introspection on your own, right? Because you don't write it anymore, you're not as actively involved in the process anymore. So that's also a reason that being on top of that modeling part, making sure that the plan, the specification, the model is on point is way more important than it used to be. Even more important than it used to be. So, what do we then need to model? Well, I think you all might have some like experience with these kinds of things, outdated readmes, outdated stuff, of course. But actually, your model needs to be queryable. Well, and small disclaimer: I let this generate with AI, so. It doesn't have to be queryable with SQL. It's just a way. It has to be queryable. It should be typed or should be strictly defined, because if your model is also just a ton of random stuff in a big bucket of text, basically, then you also run into the similar problems as you have with like just letting AI handle it. And it should be connected, so you should have internal relationships. But also it should be connected to the thing that you're actually building, so that you can feedback information into your model. Since, we just realized, you always have things that you come upon when you start coding. You can't foresee everything. So here's a bit of a visualization to show like the structured model, which we say from domain-driven design mostly. You have domains, you have products, processes, tasks, rules, and then roles or actors. And you can use that to generate a platform. But if you do that for like, well, dump everything, compile everything into one blob or chaos, and don't have the structure in there that much, then you will miss relationships, inconsistent definitions, conflicting rules, hallucinate links, and it will be usable at first. You will get something. I always say if people start using Lovable, which have no coding background, they'll say it's great, it's perfect. You can realize stuff, but if you, of course, like grow past a certain point that you need to scale something or need to make something bigger, then they usually run into this kind of problem. They actually don't know what they built, what they realized. So yeah, if we do that, if we create a proper domain model and proper documentation, these are two prerequisites, and then we focus on we use AI to generate a platform. Yeah, then we could say basically it's somewhat of a compiler. However, it is not deterministic, as a compiler mostly is, but it's still probabilistic. So there is still some like vagueness in it, and you want to minimize that as much as possible. So one thing that you also need is have a way to feedback information from your generated platform, the thing that is actually running or doing stuff, the code that you have, back into your model, because these two need to be in sync eventually. Otherwise, it's fun to start out with, but then still scaling, maintaining will be very, very hard. So yeah, this is basically a very similar picture of what I showed before. So based on domain-driven design, you have domains. One important thing is we went from like autocomplete in like small functions or sentences or function calls even you started with, completely up to like I call it platforms, but it's very important to like work in domains, because within the domain you can actually create a proper model. And if you start modeling across domains, I'm really keen to see where it goes. But for now, the domain is the model is within one single domain. You have a specific model that you keep them small enough so that you can actually generate some useful results from it. And you can also keep all these relationships clear. And just like businesses should work, in my opinion, from a domain perspective, we should also think about that if we want to make our AI assistants work effectively based on the model that we create. Yeah, well, then you have the product layer. That's the thing that you deliver to the outside world as a domain. Then you have the process, which is rather important, of course, in a model. So how do you actually deliver the stuff? So you have the scope, that's the domain. Then you tell what you deliver, that's the product. Then the process is how you deliver it. And then there we have, on the top right, we have the roles. So that's who can do what within your domain. And of course, we have a lot of artifacts. So what does that look like in practice? I just tried to craft an example for today. It's about invoicing. It's our procurement, basically. So I didn't show that on here, but it's a procurement domain where we have a domain model. And this is the very simple, for now, domain model, where you have an order form, which is basically the stuff that is supposed to be ordered. The order form has line items. It is sent to a supplier, and then the supplier sends an order confirmation, which confirms the order form, and then we have an invoice which bills the order form. And the order confirmation and the invoice both have the same line items that are also on the order form. So relatively simple domain model. So that is what that looks like. And then a process could look like this. I'll move to the side a little bit. So we have a process. So it starts on the left side. You receive an order confirmation from a supplier. Someone manually downloads the email attachment. They cross-check the line items with the ERP. They identify discrepancies. They enter the confirmed data. They track delivery. Well, yeah, and then whether the goods are arrived or not, they can follow up, and then the goods are delivered eventually. So this is a very simple, basic, straightforward process. So this is version 1. And what we did based on this information and our documentation, we generated a platform. I will show you that afterwards, because this will be the new version where we have an AI agent involved, because, well, who doesn't want to have an AI agent involved? Basically, it's just a system which does like all these tasks for you, and you can see that the process has changed a little bit because the identification of discrepancies happens by the system, but if the discrepancies are found, then it has to be validated by a user because, well, in the previous version, if it manually happens, you find the discrepancies, then you also task them. So yeah, that's how it usually happens with these processes. So something changes, so you also have to think about why is my model changing, who can do what, and how does that impact the business. I'll show the demo afterwards, because what I want to zoom into is then, okay, you say you have this business model, that's fun and all, but how do I actually generate a platform from it, right? So we have a lot of documentation, basically, explaining how to construct a platform from this specific set of documentation that we think, that we use, at least in a day-to-day basis. So this is an example of what it looks like, and this is very opinionated, of course. Because as you can see, we use HTMX, for example, in the front end. But because we have to make the translation from, well, the business model, which doesn't explain anything about how to technically implement it, to the technical application or platform that you're actually building. So yeah, and also stuff about design, about concepts, about how we think things should be structured. For example, in our backend foundation, we have concepts for the infrastructure, presentation layers, and domain layers, how they are layered, these kinds of things. It's very opinionated on how we think we should construct that. You can create your own documentation, but I want to dive a little bit into what that documentation looks like and how that then works for us to generate these platforms. So here you can see another overview is just our like main entry for like we also have to be able to understand what's happening here, of course. Here I can move into like one of these files here says like how to set up a new project using domain, product, process, Pygrunn driven, no engine. So this is from the stuff that I just showed. Here's like a little table of contents of 15 things, like all steps to basically take to go from nothing into like, well, from nothing and a business model into like a running platform. So zooming in on a couple of these, we make it very, very specific. So for example, we have the mental model of the domain, product, and process. So what is it? But we also eventually define, for example, like this is what the file structure should look like. So and everything under the modules/domains is a MyStekz domain, and everything under modules/supporting is a supporting module. And more into depth, like one domain looks then like this. We use hexagonal architecture for that, for example. All these kinds of very strict principles. Coding examples, like how should like a given file, or what should a given file look like. Yeah, and then I can show you something of a demo. So what did I do? Here you can see a screenshot from my Cloud Code, which is not that interesting. So wait, let's start here. And of course, it turns up empty. So what I'm showing you now again should be the initial process. So this is the initial process. Yeah. So which we just walked through a little bit. It's a very simple, very manual process, and this process we used. We can also have a look at the domain model, but you also saw that already. Here we have the domain model again. And this information is exposed through an MCP server, so Cloud Code has access to this. Cloud Code has access to all the documentation, and then Cloud Code made us, in this sense, a platform. And now I'll put away the mic here. Let's see if I'm a bit audible like this. Yes, okay. Oh, let's see. So I log into this this platform that it created. So all authentication, everything is set up, because that's stuff that doesn't come from the business model right now. Which roles there are comes from the business model, etc. But all these the other components like authentication, etc. are of course where we can, we use standard components. But also just description in the documentation, what's principles to use basically. So here I put in like you could see I did not try this before. Could put in something something manually. I can create something else, and then well. One. I can register it. I can see that I can then take these steps, process in ERP. I can register a delivery date. So and then we can see we either contact the supplier or mark delivered. So it's a very basic, simple process, and of course it's something that we could demo really quickly. And then we have the second version of the process. Oh yeah, I realized. I'll give you a little bit of an update on this one, because I showed you a different one and on the presentation. Mainly what I did is I only moved I created the AI agent lane here, but I left all the other stuff in the procurer lane, or what I think previously it was called the admin lane, but I only moved like the identify discrepancies here, and yes, no, it's not really an AI agent, I know. But the main point here was that I wanted to give you a live demo of what Cloud Code could do and everything, but I figured it still would take too much time for now. But that's why basically only one task has moved. So what I did is I went into, oh, that's a different presentation from Art. This one here. So I went into Cloud Code, into the repository, and I asked it, well, please take a look at what has changed in the process order confirmation process, and then it started accessing the MCP server, and then it got some information on what has changed. So the process started, well, I don't know, that's today, so fully human workflow, was rewritten 25 times, and then it's, well, these things are changed. Before it was this, after it was that, and then, well, we have a plan for the demo, and then I had to, it came up with like a more explicit plan. I said, well, just make it done for the demo, and it started making changes, quite some changes here. Well, you can scroll through it. And then I had to ask it how to run this because I had to do some migrations. But then, based on these changes, I currently am gaming the system a little bit because this is a different version running from the previous one. So this is a second work tree, and I just because in the other one I reverted the changes so I could at least be sure that it is demoable. Then here we can log into the system, looks pretty much the same. But if I fill in this stuff, then, well, you should be able to see that the discrepancies, yeah, 320, I think. And, well, a lot of clicking. I should automate this too. So now we can see that this one is waiting for validation. I can click on it and then I can review this as well. So I can see, well, review the discrepancies. It tells me like, okay, I expected this or that because there are discrepancies. So now the system checks that and then I can process that and then continue with the same steps as I did before. So walk through it and have the whole thing done. Wrong presentation again. So that's a very quick walkthrough or demo and example of how we used to generate these platforms, how we use the model to generate these platforms, which documentation that we use. And I think what I wanted to show here, at least, I asked AI, like, what should I say in my last slide? And it said, well, if you want to be relevant in 5 years, then you have to focus on modeling now, and otherwise, blah, blah. And I was like, yeah, it makes sense, but it makes sense like 50 years ago too. I mean, if you don't know what you're coding, then, well, don't start coding, I would say. So think about, especially when you want to make systems that can scale, think about what you actually want to do. So understand, design, and align before you actually build it. And there's a nuance there, of course. Also build it, or build versions of it. Build like small proof of concepts because that's very easy and that helps you, of course, with the understanding, designing, and aligning. But make sure that everything that you do is grounded in the model and not. So that's why the feedback loop is also important, right? I didn't show it today, but from the platform we can feedback the information into the model, and then we can see how it performs. But I don't say don't use AI tools to make proof of concepts. Of course you have to do, because that really helps you to construct the proper model, like this part. And if you do it the other way around, then you get like patching all the way, guessing, reworking, and well, you get some fragile results. Yeah, that was it.